Hello, so welcome back again to our channel, and we continue our exploration of variety of analog and mixed mode signal circuit designs. And in continuation to that, what you see on your screen is a circuit that consists of three operational amplifier labeled as A1, A2, and A3. So we have got an input voltage V in, that is a voltage applied to the negative pin of A1. And at the third amplifier, at the output at this node, we are interested in determining the output voltage V out. So we have to find the expression for the output voltage. So if the component values, for example, all resistors are given, we can also get the value for the V output voltage. And of course, we need to know what is the value of input voltage. So let us derive step by step the expression for the output voltage. So obviously, we will investigate the circuit step by step. As you can see, the very first stage, that is A1, is configured as inverting amplifier here, the A1. Why? Because the input is applied to the negative pin of the amplifier, as you can see, while the positive pin here is grounded, and there is a feedback of through the resistor R2 to the negative pin. So feedback is negative, and that's why we see that this is an inverting amplifier. So we know that if we see the VO1 is the output of the A1 amplifier stage, so we can write here VO1. We know that is output is gain multiplied by the input, and gain is determined by RF by R1, but RF is actually the feedback resistance. Here it is R2, so we will write that accordingly. So let me write here. So I would say this is an R2 divided by R1 multiplied by V in. So that's your first stage for the stage one, that is A1. Okay, and this is an inverting amplifier. Now, if we look at the second stage, that is A2 right here, and we are interested at the voltage at this node. So V in is coming to the positive pin of this amplifier, whereas there is again a negative feedback provided at the negative pin of the amplifier through this resistor R2. And we see that this is clearly a case of non-inverting amplifier. Non-inverting amplifier. So also from the basic theory and our understanding, if we are asked to derive or write the expression for the VO2 at this node, we know that it is again the gain multiplied by the input, whereas the gain is given by 1 plus R2 over R1 multiplied by V in. That is for the stage A2, which is a non-inverting amplifier. Okay, so we have determined the expression for VO1 and VO2. Now, VO1 and VO2 becomes two inputs to the third stage, that is A3. So VO1 comes through this resistor at the negative pin, and VO2 also comes through this resistor at the negative pin. So basically, we can see is also A3 is also biased or configured as an inverting amplifier. And we can see that this is basically a summing amplifier. So we'll write here. It is acting as a summing amplifier, or we can say that this is acting as an adder, or it is also called as weighted sum difference amplifier, or simply amplifier. And all three names are configured as inverting mode of the op-amp. Inverting mode of the op-amp. So obviously we can write the expression for the V out, that is the final output here, is going to be minus R4 by R3. That is, this feedback is negative right here. multiplied by VO1, that is this input, plus minus R4 divided by R3 again for the VO2. This is VO2 and VO2 is right here. So we can simplify the expression further. V out will be equal to minus R4 divided by R3 VO1 plus VO2. So this is basically a adder circuit in inverting mode of the operational amplifier. Furthermore, we'll write minus R4 divided by R3. VO1 has a value of minus R2 divided by R1 V in, and that's the case right here. Plus VO2 is this value. We'll write here 1 plus R2 over R1, and this is also V in here. So can we solve it further? We can take the V in common here. So again, minus R4 over R3 in bracket, you can see that V in, if taken common, we'll have the square bracket, and then we'll say that minus R2 over R1 plus 1 plus R2 over R1. So that is how this simplification goes. So just you can see that you have this R minus R2 over R1 plus 1 plus R2 over R1. So let me write here. So it will be minus R4 by R3. In bracket, you have V in, and in bracket, your minus R2 over R1 and plus R2 over R1, that gets cancelled, and then it remains only 1 here, and final output will be minus R4 over R3 multiplied by V in. That's your output voltage. So gain, final output is gain multiplied by input, and the gain is provided by the ratio of R4 over R3. If you see that I have done it correctly, so put your opinion in the comment section. And if you see any error, that also you can put and write in the comment section. So hope you found this module very useful. If you did so, share it with others for wider reach, and stay tuned for more engaging content like this. Till then, wish you happy learning. Okay.